The basics of using it, and also how specifically we're using it in our Udemy Android app. So just out of curiosity, how many people in the room have played or using Exoplayer? All right, that's quite a bunch. And how many are using MediaPlayer or used MediaPlayer in the past? Awesome. So for those of you who haven't used Exoplayer before or don't know what it is, it's an application-level media player for Android, and it provides an alternate way for playing videos other than using MediaPlayer. It's an open-source, third-party library made by Google, written in Java, and it relies on low-level media encoding APIs. When Udemy first wrote the Android app, we were using MediaPlayer, and about 6 months ago, we decided to change it to Exoplayer. The Udemy app is used to view courses and video lectures, so the media part of it is one of the core functionalities of our app. And it was important for us to use something reliable and stable, and we also needed something customizable, and to be able to add functionality beyond the basic play, pause, next. MediaPlayer has advantages. The main one is that it's really easy to get started with and get it to work. You basically only need these 3 lines of code to play most files. And the disadvantage is that it's not customizable and it's not extensible. And over time, our needs at Udemy grew beyond the play this video to add more features and support for things like HLS or variable playback speeds. And we just couldn't do any of that with the media player, and that it doesn't support out of the box. MediaPlayer also has other disadvantages. It's a black box, it's written natively, so it's impossible to debug or figure out exactly what exceptions are happening or why, forcing us to resort to this piece of code that's basically saying, I don't know what happened, just try again. MediaPlayer is also installed locally on your phone. Therefore, there could be differences in implementation and the way it works on different OSs and different phones. And we can't control or guarantee exactly which version will be used. Not all of them correspond correctly to this great state diagram. And a lot of these states can be buggy. And when they are, like I mentioned before, it's really hard to debug them. The media player sends out weird exceptions codes, and we couldn't see for certain what crashes are happening, especially when they're happening on specific devices, but not on others. Exoplayer provides an alternative to that. It's very extensible, but it has a steeper implementation curve. It solves the problems that I talked about before. It's open source, it's written in Java, so it's really easy to debug, to read, to figure out what's going on in there. It's built on top of Media Codec, which is more low level, so the chances of encountering specific phone or OS issues is way less. And it handles HLS correctly, something that MediaPlayer didn't do for our HLS files. It's also extensible and or supports out of the box things like background playing and subtitles, changing the playback speed during playing, and variable resolutions. So let's go over the basics of using Exoplayer. And I wanted to start with some tips. The first one is, again, Exoplayer is written in Java. That means that anything you can maybe have a question on, you don't know exactly how it works, you don't know what this variable means, it's really easy to just dive into the code and see exactly what's happening and where or why it's using it. Another tip would be that the sample app provided by Google is a good place to start. It has the basic architecture that you can easily adopt, and most of the implementation there is good and applicable. And the third thing is that the default implementations for classes are good implementations. We found out that most of the time, even though we can technically extend or replace them or write our own things, they're just good. They just work. So even though it's a lot of code, you don't have to really think about most of it until you have a problem or you need to change something specific. You can just use the defaults. Everything will be fine. Exoplayer implementation requires a little more programmatically to even just get it started and play videos. The work can be roughly separated into two parts. The player that is controlled through the UI to perform the big actions like play, stop, next, and the engine or the core parts that fetch the stream, decode it, and process it for playing. And this is an example of how a player instance is being instantiated. And the player control is a default component that is being used to communicate with the player. This part looks a little bit like the MediaPlayer part. In order to get information from other parts of the engine to the player and for it to respond accordingly, for example, by adding retry cases in case of failure, the player can listen to a bunch of events from the core engine components. The core is a little bit different if we're dealing with playing non-adaptive stream types, such as MP3s or MP4s, and it gets a little more complex with HLS and Dash. And I'm going to start by looking at the simple types. You can look at this diagram from both directions, both from left to right and from right to left. From left to right, it's like the journey of a stream. It comes from the server by the default URI data source. It's extracted by the extractor sample source that also figures out the correct exact extractor to use. In case of MP4, it's MP4 extractor. It opens the file and decodes the audio and video into raw audio and video that the renderers can feed the player, and the player will play them. What actually happens is the other way around. It's the player who starts asking for the buffers from the renderers, and then they go back and say, maybe we don't have anything. Hey, extractor sample source, give me something. And extractor sample source might say, hey, I need to fetch something. I will use the default URI data source to do it. So again, this looks like a lot of code at first glance. Do we really need all of that just to get going? The answer is yes, but we don't need to think about it too much. Most of it is just default things. Again, I copied this directly from the demo app. And just as is, copy-paste, this will work. So there's no need to spend too much time on figuring out exactly what each and every part here does. If we go back and think about the building blocks that we saw in the previous slide, then this is what they are. The default URI source that is being given to the extractor sample source, and the renderers, which is an array of renderers. In this case, I only put audio render there, but for video, we will have a video renderer, and if we want subtitles, we would have a text renderer there. We give them all, we put them all in this array, and then we give them to the player to use. In Udemy, we made some customizations to the basic structure. And for example, we decreased the buffer size and the segment size after getting some out-of-memory exceptions on low-end devices. And the other thing that we did is, because the extractor sample source basically goes over and selects the correct extractor to use, we already know what type of files and what type of media we're playing. So we could give it only the types of extractor that we wanted to use and avoid a part where it goes over all the extractors and try and figure out exactly what type of stream this is. And that's basically it. That will play MP4. For HLS, things get a little more complicated, because HLS is a stream that is broken into a sequence of small file downloads. Each download is a short chunk of the overall stream. And as the stream is played, the client may select from a number of different alternate streams that are encoded at different data rates, allowing the stream session to switch between them during playing based on logic such as bandwidth. At the start of a streaming session, the client downloads an extended M3U playlist. It's a text file that contains the metadata for the various substreams which are available. So HLS uses a new source to manage this decision of which chunk to use based on available bandwidth, and to switch between those chunks successfully. The rest of the stream is pretty similar, and all the decision-making about which stream quality to choose and switching between streams is handled by the HLS chunk source and HLS sample source. So we don't have to, again, we don't have to write custom logic for that unless we're unhappy with the defaults. And in our case, we were happy with them, so we didn't need to do any extra logic for our app to just choose the correct file and to choose the correct quality to stream. And this is the example of instantiating the new HLS chunk source. It uses a bandwidth meter to calculate the current available bandwidth and a PTS timestamp to adjust the PTS timestamps contained in a chunk with a given discontinuity sequence. If you don't know what that means, that's fine. I'm not sure I do either. Like I said, the default works, so we didn't go into too much digging around that. And the other interesting thing is that you can choose how you want adaptive mode to be handled, which is the last parameter given to HLS chunk source class. And you can choose between none, which means that whatever was selected when the video was started is going to stay the same throughout the play. Splice, which means that while switching between chunks, it will download the old one and the new one in case the previous one doesn't end exactly where the new one starts. And that helps because the user otherwise might see a glitch in the video when switching between chunks. Or abrupt, which means that it will download the new chunk but not the old one. And again, if the timestamps don't match, then the user will see a glitch when switching. And this HLS sample source, again, takes that new chunk source that we just created. HLS chunk source this is basically an example from the debugger about how HLS chunk source has taken our meta file and composed a list of possible streams to choose from and how it holds that information. Another thing that we needed to do at Udemy is to overwrite this. We wanted sometimes to give the user the option to just say, I want to use this quality and nothing else. And that means that we had to customize HLS to say, OK, don't change qualities dynamically. We just want that one, and we want to stick to it. And this flag, the abruptive mode none, means that whenever quality was selected, will not change throughout the video playing. And that is a good part of what we want. But we also need to be able to tell it which quality to choose to begin with. It starts with a default value, but what about manually changing it? And that, unfortunately, involves manually setting this private int selected variable index, which is a private field that is used throughout this class, and particularly in this method, getChunk operation, which performs the bulk of the work in this class. And that means that we needed to create our own instance of this class to add this functionality. And that was sad. Another thing that the Udemy app supports is the background media service. which means that we want our app to continue playing in the background in audio mode only, while displaying a tile notification that allows the user to control the media. This is actually a functionality that we already had when we were using MediaPlayer. But in MediaPlayer, this was harder to do because we instantiated another instance of MediaPlayer specifically in the service, and then had to communicate information back and forth from the activity to the service all the time, whenever the user switched. Exoplayer has audio and background capability built in, so that actually makes things way simpler. The first thing to do when switching to background audio is to clear the surface of the player so it will not be attached to a view. And that means the audio will just keep playing in the background. This line of code just sends a message to the player that says, set the surface to null. Funny thing, if you try to run the sample Exoplayer app, you'll see that the background audio continues for a few seconds and then dies off. And that is because the app's process is being killed off. Creating a service prevents that from happening. And also in the service, we can create the notification tile and control the instance of the player. With both the service and the activity using the same instance of the player, there's no longer a need to sync between them like there was in the old MediaPlayer. So again, our code is made way simple. When the activity resumes, we can reconnect the surface from the view to the player and just continue playing seamlessly. Another thing that the Udemy app supports is subtitles. And with subtitles, we actually had some issues with Exoplayer. Some of them were that it doesn't support SRT files, which are the majority of our subtitles. If you want to instantiate subtitles, you would actually instantiate another renderer, which means that the video will completely crash in case of error, which was something that we didn't want to. We wanted the video to just keep playing and not play the subtitles if they were faulty. And we wanted to support multiple formats like UTF-8. We are having subtitles in many different languages, so we needed that functionality working. And our solution was just to feed the subtitles manually. I'm not going to go into too much details about that, but the basic of it is just a runnable that chooses the position for the subtitles from the file and posts them in the view. And for all the complex, maybe parsing of the file and figuring out exactly what are the timestamps and the things like that we needed for subtitles, we just used this subtitle conversion library. The last thing I wanted to talk about is the variable playback speeds. And that's the ability to play a video at a slower or faster pace. And that was actually one of the top feature requests we had, and something that we couldn't do with MediaPlayer. And it was one of the first things we added to Exoplayer. So in Exoplayer, video always follows audio. There's always logic to keep them in sync. And it's always about audio comes first, video will follow. So our idea was if you make the audio run faster, the video will follow along and will also play faster. And there's a library that does that takes an audio buffer, makes it faster or slower, and returns a new buffer, and that's Sonic. It's available both in a native version and a Java version, and we use the Java because we like to know what we're reading about. And the component that we need to extend is the audio renderer. We basically wanted to tell the audio renderer, instead of using whatever buffer you have, we will take that buffer, pass it to Sonic, get the buffer back from Sonic, and this is the buffer that you're using now. And that's basically what we did. We just extended the media codec audio track renderer. In it, we overrode two methods. One of them was onOutput format changed, which happens most of the times when a track is first initiated, first instantiated. So in this method, what we're doing is we're setting up all the Sonic-related buffers and the Sonic class itself. And the last part is flushing the stream in case there was something there before playing in a different speed, and setting the speed to whatever the user has selected. And the other method that we overrode was the process output buffer, which is the actual part that actually takes the buffer and plays it. And in it, what we did was we got the buffer, we wrote to Sonic the buffer, and then we read back from it the buffer that is now modified with our speed. And we gave that to the superclass to continue using. Sometimes we would originally read or write, more to the point, to Sonic more than we read in this particular instance. So we didn't always have to write more into the Sonic buffer. Sometimes we could just use whatever was already processed and feed it back. If we want to change the speed in the middle of consuming a buffer, we would have to flush the stream and set a new speed. And then next time it requests a buffer, it will just go, OK, now I need to write and read from a new buffer. OK, thanks. Questions?